Hey, this is Andrew Brown, the CEO of Exam Pro. Today is October 3rd, 2019, and we are at AWS Toronto Summit, and I have a talk for you, which is on the fast track to microservices on AWS. So before we jump into what kind of services we can use to run microservices, let's just lay the foundation what a microservice is. So for the last decade or so, people have been used to launching a single server and putting everything under the sun within it. So that could be your front end, your back end, your marketing, and services such as caching, database, and load balancing, and your background jobs, okay? And so the idea is that when you wanted to scale this, you would just choose a larger instance size, or maybe you would start decoupling these into other servers. And this is where microservices came in, because it's just where things became extremely isolate and small. So if you are using many AWS services in combination, which you probably are, you basically are using microservice architecture, at least from that standpoint. But this talk is really about taking your backend code. So when you have your API, your ORM, and your background jobs, and breaking those up into further isolate applications. Okay, I call that the orange stuff, and that's what we're going to be exploring today. So to break up that kind of stuff, we have a lot of options available to us. In fact, we have 5 AWS services, and this is where you have to know the difference between all 5 of them to choose which one is the right one. We do have some supporting services that do make working with microservices easier. We're not going to cover these. We don't have time for that, but we're definitely going to walk through these 5 here, starting with Elastic Container Service, also known as ECS. And so I always think of the service as Docker as a service. And the idea here is that you're going to just choose the EC2 instance that you want to launch. And then it's going to, when you want to run your Docker containers, you're just going to create a task or service and launch it, and it's going to then run it on that EC2 instance, okay? And so just looking at a architectural diagram over here, and we're just going to walk through these components. So the idea is that when you use ECS, you're going to be launching a cluster, and all a cluster is a bunch of EC2 instances, which we call container instances here, which are going to contain your tasks or services, all right? And within those tasks or services is what's going to contain your containers, okay? But let's just talk about tasks. So again, tasks is just a grouping of containers, okay? And to define what containers are allowed to launch within a task, you're going to create a task definition file, all right? And then you have services. And so services are just like tasks. The only difference is that services don't end when the task is done. They just keep on running. So if you are running a web application, you definitely want to launch it as a service because you want your web app to continuously run, whereas the tasks are really great for background jobs, all right? And there's just one more thing. We have container agents. So container agents is a little script that is running on that underlying EC2 instance, which is going to then communicate things to monitor the tasks that are running, whether they're stopping or starting, etc. Okay, so that's how ECS is coordinating all that kind of stuff. So now that we have an idea of that architecture, let's look at that task definition JSON file, okay? So on the right-hand side here, we have a task definition, which contains 2 containers defined. And if you have figured it out, we are launching a WordPress, okay? And so we have WordPress backed by MySQL. All right, and so the idea here is that when you define these containers, you're gonna have to give it an image, okay? And so these images are just like when you would be creating a Docker file, you're specifying the image location, which could be from an official repository like Docker Hub, or if you need to keep your images private, this is where you can leverage ECR. And that's all ECR is. It's just a fully managed Docker container registry. So you just store your private Docker images on there so you can reference them here for ECS. Okay, and so when you do define these containers, you do have to specify at least one essential container. And the idea behind that is that it is like the linchpin to everything. So if it's not running, then nothing else should be running as well. If this creating this task definition seems cumbersome, AWS does have a very nice wizard to help you create that file for you. So don't feel too overwhelmed by that file. And also just notice that you are specifying the memory and CPU allocation for those containers, okay? So when you spin up your EC2 or you choose your settings for your EC2 instance for ECS, you're going to have to choose the instance type. And then here you're just dividing up the amount that is going to be used by those containers. So now let's just look at actually how to create an ECS cluster. So you're going to have quite a few options available to you. So you can choose Spot to start saving money on the EC2 instance or on demand. You're going to choose that instance type. So on the right-hand side, you can see I have a T3A large chosen, and you can choose the number of instances. And then you will need to choose the AMI. So we have Amazon Linux 2 and Amazon Linux 1 there that we can choose from quickly. And then you'll have to choose a VPC or create one on the fly. You then can assign an IAM role, and then you have the option to turn on CloudWatch Container Insights, which is kind of like detailed metrics plus the CloudWatch agent giving you more host metrics. So it's just a lot more detailed information about the instances that are running. And you can also choose a key pair. So these EC2 instances that are launched for you, you can actually SSH into. Not recommended that you do so because you should really leave them in their vanilla state. But if for whatever reason you needed to, you definitely have that ability to do so. Okay, so now that we've covered ECS, let's talk about Elastic Beanstalk. And so Elastic Beanstalk, I always think of it as the Heroku for AWS. Okay, and so if you've never used Heroku is a very easy and convenient way to deploy web applications with very little knowledge. And Elastic Beanstalk also accomplishes that goal and can launch microservices on AWS. Okay. So just jumping into Elastic Beanstalk here. So we have our nice architectural diagram, and it's basically exactly the same as ECS, except we have this nice big box around that says Elastic Beanstalk environment. That's because Elastic Beanstalk is actually just using ECS. Okay, it is using Elastic Beanstalk is just a CloudFormation template, which sets up a bunch of resources for you, so you don't have to think about it. And so, of course, it's going to use ECS under the hood. So when you create your application or environment on Elastic Beanstalk, it's going to create that cluster for you. It's also the extra advantage of running on Elastic Beanstalk is that it also can configure other services that you might need to integrate with, like RDS or Elastic Load Balancer or SQS. Okay. And also Elastic Beanstalk has a very nice dashboard. So if you want to just have a better visibility on all your stuff, then you're going to also get that with Elastic Beanstalk. Elastic Beanstalk isn't really recommended for production use. And when I say that with quotations because we are really talking about for enterprises. If you are a small startup to medium-sized startup, it's totally fine to use. Okay. Now, in order to launch your containers onto Elastic Beanstalk, you're going to have to configure a Docker run to AWS JSON file. And this file is eerily similar to the ECS task definition file. If you open them up, they're going to look very similar. There are definitely variations there. You do have to manually configure this there, so you can't use a wizard for that. But it's, again, not too difficult. But once you do that, you just zip it with any additional code that you want to do, and it's just uploaded and it just deploys. Okay. Now with Elastic Beanstalk, you do get a CLI with it, which is abbreviated with EB. If you ever use Heroku, their APIs are eerily similar. Okay, so if you're coming from Heroku, you might find it you're right at home there. And the cool thing with the Elastic Beanstalk CLI is that it makes it very easy for you to run your microservice, whatever you define that Docker run file locally. Okay, so if you're not ready to run it on AWS, you can run it locally and use it for development. So that's very, very nice. So in order to create that Elastic Beanstalk environment, you're going to choose the environment. And so you have two options. You can choose web server environment or worker environment. Web server is going to launch if you choose high availability, it's going to launch a load balancer for you. It's also going to give you this domain so you can actually access the running web application. Okay. And if you have a worker, it's going to launch an SQS queue for you so you can interact with that queue to run background jobs. So that's the big advantage to Elastic Beanstalk, is it's going to set up those other additional services so that you don't have to do that yourself. And then you just choose that multi-container Docker. You'd upload your code with that zip containing that Docker AWS JSON file, and you're going to choose your configuration. So you can have it low cost or high availability. High availability is going to do a bunch of extra stuff for you, but it's nice to know that it's very easy to go from cheap or to highly available with one click there. And of course, you have more configuration options there. So if you want to configure your instance or your load balancer or your security or etc., they have all these nice little boxes here that you can use. So now on to AWS Fargate. So Fargate, I always think of it as like the fully managed version of ECS. So the idea here is that you do not manage the EC2 instance. AWS is going to manage the instance for you, okay? So when you are just looking at our architectural diagram first, it looks kind of similar to our ECS one, except there are some things removed. So the idea is that you define an ECS cluster just as you always would, but you wouldn't be provisioning an EC2 instance. And when you needed to run tasks, you would just launch your Fargate tasks or services, and it would spin up a server on a need-be basis, okay? Just like an AWS Lambda, all right? But the huge advantage here with Fargate is you do not have to provision or configure or scale those EC2 instances, okay? AWS is going to take care of it for you. Now, Fargate is very similar to Lambda, so it's definitely worth comparing the two. So they both automatically will launch and terminate instances for the duration needed, so you're not paying for idle instances. They both have cold start, so that is a disadvantage. So that means, there's some time before the first instance runs, and then the instances after that will be a little bit faster because the EC2 instance is running. Fargate does have cold starts, which are shorter. So your containers do launch faster on Fargate. It's debatable as to how much, to what degree. So it might not really matter that much, but it is faster technically, okay? Fargate tasks can run forever, whereas with a Lambda, they can only run up to 15 minutes. A Fargate task can use up to 30 gigabytes of memory. Lambda maxes out at 3 gigabytes, and Fargate, you can customize the containers, where Lambda, you can only customize the runtime on a standardized container, okay? So you're gonna have a lot more flexibility and control here with Fargate over Lambda, all right? And just when we want to configure and launch that Fargate task, the idea is you're going to create your task definition there. And this is where you can just define the memory and CPUs you want to use. And you are going to then allocate how much within for those each containers within that task there. When you do create task definitions, when you launch a task, whether this is for Fargate or ECS, you get to say what VPC and subnet you want to run it in. You can apply a security group to it, and you can also apply an IAM role, okay? So if you're just wondering how do permissions work, it's at the it's going to be at the task level, all right? So now we're moving on to Amazon Elastic Kubernetes Service, also known as EKS. And this is Kubernetes as a service, okay? So the idea here is, what is Kubernetes? So Kubernetes is Google's open source container orchestration system. It's also known as K8 for short. The 8 is for the 8 letters that precede after the K, excluding the S, okay? So that's why it's K8. Otherwise, it'd be K9, and that's just dogs, and that's confusing, okay? And so in Kubernetes, tasks are called jobs, instance containers are called worker nodes, and so the big advantage of using Kubernetes over ECS is that if you're already using K8 for your workloads, okay? So, if you're already using AWS, I always recommend ECS over K8. But if you are worried about vendor lock-in, K8 is an open source project, so you can run your workload here. And if tomorrow you need to move to anything else, you can do so, okay? And K8 is secure by default, so that is very nice as well. Now, to actually use EKS and set up EKS cluster, you're going to have to first create an EKS service role. You're going to also have to create a security group to launch that EKS cluster in. Once you've launched that EKS cluster, you're going to want to install and use the kubectl, which is the K8 CLI, to communicate to that cluster on your local development machine. You're also going to want to install AWS IAM Authenticator to authenticate. And to actually launch your the actual worker nodes, again, those are like container instances. AWS provides you a CloudFormation template to launch those instances, okay? And so those worker nodes can only use Amazon Linux 2. So if you do need to make changes, understand those are the limitations under it, right? And that Amazon Linux 2 does have Docker and kubectl and AWS IAM Authenticator installed. Okay. And when you want to run a job, you're going to be using the CLI. That's how you have to run the jobs. There is no interface. Okay. And so down below, you can just see I have a job, which is defined in a YAML file. If you open up the YAML file, it's going to look kind of similar to your task definition file. Okay. Where you're going to define how things are allowed to launch there. But the difference here, it's going to be in pods. All right. And so there, that's EKS. And so onto AWS Lambda. So AWS Lambda is a serverless is a serverless service. So if you've ever heard of Lambda, it's highly associated with serverless. Okay, and just jumping into it here, the idea with Lambda is you do not set up the container. You have a predefined container, and you're able to run or use a runtime. Okay. And the idea is that you just have code and you upload your code to Lambda, and it's going to then start up that EC2 instance, okay? And it's going to then just place that code onto that EC2 instance and then use the runtime that you chose, all right? Now, the cool thing about AWS or Lambda is that it's super, super, super cheap. So you're only paying for the compute time, right? Because it starts and stops the EC2 instance for you. And it already has the SDK pre-installed, so you don't have to bundle that within there. And to actually run a Lambda function, you have lots of integration into AWS, so you have a variety of services that can trigger that Lambda function for you. Okay, and you do have some ability to bundle in some binaries or other dependencies onto the container there as layers, okay? But there are some limitations to Lambdas. So Lambdas can't run longer than 15 minutes. There is an upper limit on the amount of memory you can use, and you don't get to configure those containers, okay? Now, just to look at some of the configuration options here, by default, Lambda doesn't run in a VPC, but you can launch it in a VPC if you like. And I shouldn't say no VPC, it's probably just a managed VPC by AWS. If you need to specify, you can specify the maximum time there. So here you can see I maxed it up to 15 minutes, but you can definitely reduce that time there. And the idea is that if you don't want anything to run beyond that time, it's a good way to save money, right? So things won't run ever beyond what it needs to run on. And they can, of course, end sooner. If the task is done, it's done. But just for the upper limit when it should stop or quit, okay? And then you have your memory, so you can max that out to 3 gigabytes there, okay? So 3 gigabytes, so that's the max that you can do there. And the nice thing is that the Lambda interface has a nice little UI here, so you can write your code right in line there. If your code gets a little bit too large, then you do have to upload it as a zip. And if it gets too large, then you can't use this interface. But it's nice to have this kind of flexibility for development. Okay, so that's just kind of the configurations and benefits there of Lambda. So now let's look at pricing. Pricing is such an important topic that everybody wants to know, because that is going to be a huge factor for you here. It is a little bit difficult to compare these side by side. So some of these comparisons aren't fair because it's going to be based on the use case of what you need. But let's go through it anyway and just try to baseline it to something as close as we can, okay? So the pricing here is going to be for Canada Central because we are at AWS Toronto Summit, so let's use Canada prices. But the prices are always in USD, so just bear in mind we have to change our quarters into loonies there, or whatever the conversion is. And so if here's a little hack for you whenever you're trying to calculate EC2 instance prices, is that you're always giving the per hour, right? So whatever that is per decimal point. And if you want to figure out the monthly cost, there's about 730 hours in a month, okay? So if you times that, you get the general cost for the month, okay? So starting on the left-hand side, Elastic Beanstalk and ECS are grouped together because EB is using ECS underneath, so the pricing is going to be the same. And so you're paying based on the EC2 instance per hour. You can reduce the cost by using spot or reserved instances. So the pricing here is on demand. So if you can definitely reduce this cost significantly, okay, like 75 to 90% off, depending on your commitment, okay, and your tolerance to tasks being interrupted for spot instances. But if we had a T3 micro, so that's 2 virtual CPUs and 4 gigabytes, and we ran that for a month, that's $33.87, okay? So if you're using EB, there's very little to no management. But if you're using ECS, there's a lot of work involved there. So you do have to consider your time involved, or whether you can use EB in production based on your use case. Then you have EKS. EKS, you're paying for the cluster running because you have to run the control plane and a bunch of other stuff to manage that Kubernetes cluster. And so that is per 20 cents per hour. Okay, so it's going to be very similar to EB and ECS because you do launch EC2 instances as worker nodes. But you do have that additional cost. So you're going to have to add that cluster costs in there. Okay, and so you're going to get a total of 179. So this is a bit steep if you are a small startup, but if you are using Kubernetes and you're very serious about it, this cost is really just that one-time cost, right? So it's never growing beyond that. So you do. So just keep that in consideration. Then you have Fargate. So with Fargate, tasks can run per second, but it's going to round up to at least the 1 minute minimum. All right, and then beyond there, I think it's in the seconds. And you're charged based on two metrics: the CPU and memory. Okay, and so your CPU and memory have different per subcent costs there based on the CPU and GPU. And again, we're going to keep with that 2 CPU and 4 gigabytes of memory there. And so going through the math here, running it for a month, we're looking at $79.26. Of course, if your tasks aren't running all the time, you're definitely going to see a lot of savings there. And also you are not doing as much work. So just take that in consideration because, maybe not having to worry about that stuff is going to be more cost effective. Now you do have cold starts. So if you have things that are critical and they have to get running immediately, you're not going to be using Fargate for that. You're going to be using ECS. But just understand that overall it's going to be more if you're running around the clock, but it is less in other regards. Then you have Lambda. So Lambda is billed per 100 milliseconds for runtime, and the cost is going to scale based on the memory. So the more memory you use, the more expensive it is. And it's also requests. I didn't calculate requests in here because I'm just not sure. And you do get a lot for free, so I wasn't too worried about including it. And it really would be good to have a comparison of the Lambda based on like how more expensive it gets per gigabyte, because I'm not sure how that scales. But the max is 3 gigabytes. So looking at the most expensive solution and doing the math there. So if it's 100 milliseconds, we got to times it to get to the second, to the minute, and then to the hours for the month. And that's going to be 128.69. Now that is a very unfair comparison because Lambda is very, very, very cheap because you get like a million requests and runtime. So you get a lot of stuff for free month over month. And generally you don't want to be running you don't want to be maxing out your Lambda functions anyway. So they're really good for short and small tasks. And based on how you architecture your application, if you break it down to really small functions, that cost can be a lot more cost effective. So to really get the full picture of Lambda, I feel like I'd have to make a more detailed comparison, which would take up an entire slide. But, just looking at that base cost, if we wanted to compare against that, you can see it's overall expensive, but it makes sense, right? Because the further you go right, the more managed and less work there is. So the overall cost is going to be more at that full on thing, right? So there's that consideration. Now we need to know which microservice to choose. So just looking at all 5 of them, let's just kind of break it down. So if you want to use Elastic Beanstalk, it's great for development workloads, and you want to get up and running with ECS very quickly. And you might want to integrate with other services, so you want them provisioned for you, such as RDS, SQS, ALB. So you're going to save time there. Then you have Elastic Container Service when you want to manage your own EC2 servers, or you want to save money. So when people power is not as worth it as saving money for the computational stuff, then you're going to want to manage ECS yourself. Or if you want to make configuration changes to the underlying EC2 container instance, okay? Maybe you want to SSH in there and do some stuff or harden your container there. So, just those considerations there. Then you have Fargate. So Fargate, you don't want to provision your instance. You kind of want to have like all the benefits of Elastic Container Service, but all the benefits of Lambda, okay? But then you also get the unfortunate downsides to like a Lambda, which is the fact that you have cold starts, okay? But the huge advantage here with Fargate is you can have very long running tasks, you can configure containers, and you can increase the memory and CPU usage well beyond what Lambda can do. Okay, so for those larger and longer tasks, Fargate's going to be your choice. Then you have Lambda, so it's really good for short running tasks with memory that is less than 3 gigabytes. And you can also control that cutoff time. So by being able to say that things time out, you can really control your costs. You don't need to configure your own containers. So you can't choose the OS on it, but that's the advantage there. It's just pre-configured for you, and you just choose your runtime, upload your code. And Lambda is really good if you want to save a lot of money. Okay, and then you have Elastic Kubernetes Service. And so this is if you really like open source, okay, if you want to avoid vendor lock-in, or you're already invested in K8 for microservices and you like some of the unique features here, which I didn't get into, then that's going to be why you want to use EKS. So, thank you for joining me for this tech talk, and hopefully that is cleared up some stuff for you about microservices.